Hello, I do this video for a little reminder for myself and for maybe interested people about this Cuda team in Python. And my previous statements were that it is rather difficult in Python to submit some structures or mixed data types into Cuda kernel, but I explored it and trained myself a little bit here, and I show right now a feasible opportunity to submit different type of data in one in arrays. Across the array that is submitted, the data type need to be consistent, but it can be easily converted. And we explore here and this class vertice and its initialization, default arguments, and here we observe this mixed data type occasion. First off, indice here is integer, and other data types here follow as floats, and then it is a list here, and inside the list are also the floats here. And it's not a practical example, but it is an example about those data types and how to submit a custom object to the list of objects. We see vertices, they are multiple vertices when we submit to the GPU. And for this purpose I made this pack function here. And the pack function, we see this one here, and this one returns a list about the arguments that the members, those member values inside the vertice, and those values you just self-compose that are necessary to submit to the GPU work there. And about this asterisk, this is the unfolding for this list. And I tested it also that if I could submit a list this way, but this is not possible. You need to unfold those into a one-level list like this. Then it consists of 1, 2, 3, 4, 5, 6, 7 members here, and the last member is then found through indices 6, because indices start with 0. And let's have a look how it's used. The class is vertex, and then we scroll here and observe those sentences that create and use this vertex. And first off, we create and generate this list of vertices. This looks like so, and we call on the spot this pack function for this list. This way we don't have those objects themselves, but really the representation of this object. And we do it 99 instances of it. And then we create another second array from this array. And this looks like a numpy AsArray and verts. And good thing about this that this list of vertices then is a two-level list. First one is all the vertices, then the second list inside it is the two-dimensional list, and the second list has those vertice ingredients there. And here is an important thing to do, the data type. We wish to submit those arrays as data types, and of course normally it should be a float here. But for this example I just use this character data type 1 byte to test out what happens. Does the numpy array remain consistent with this list build-up? And finally we create the Cuda type of array from this numpy verts. Here we see it, Cuda numpy verts, and we send it to device. And when we call this kernel, then we just submit this on-device array to the kernel. This way it's much faster, because it resides already on the device. And here when the kernel is called, then we just get this verts argument here. Finally, this is the vertice array. And here the test about to prove how it works was I created this new variable here and queried the fifth index in this array and the last element of the array. And I created a little change here that proves that really this the fifth element of the array is found. And as we see here, we see this the fifth element is 255, meaning it is in this example. It's normally not for the practical purpose, but for this purpose I use this number as in form of 1 byte integer. As we saw there, we converted it into a byte data type here. It is here here. And this is a good thing that we can just with a little effort convert those data types also. And then inside the kernel I query this fifth element, and I submit this argument here for the setRGBA function, and I just modify this part of it to come up with a red color here inside the cursor, this one. And let's take a look how it works. I just run it here. I need to submit the screen, and we see it is red color here.